Hello Math 1 students, this is Mr. Liao again. We're going to do section 10.5 using parallel and perpendicular lines. This will be split into two lessons, so today we're just going to go over example 1. It's a multi-step process, so hopefully you'll be able to follow along. So our goals will be to prove the slope criteria for parallel lines, find the distance from a point to a line, and then on the second part of the lesson will be finding the distance between two parallel lines. Essentially what we're doing today is going to be finding the distance from any point to a line and calculating that. So if you recall back from chapter 3 or 4, I don't remember exactly when, but we learned that two lines are parallel if and only if they have the same slope. So that's the only way two lines are parallel. Their slopes have to be equal. The other thing that you want to remember is that two vertical lines are parallel. Recall that vertical lines have undefined slope. So we're going to need to remember the slope of perpendicular lines. Two lines are perpendicular if and only if the product of their slopes is -1. Horizontal lines are perpendicular vertical lines. So if the product of their slopes is -1, that means they're called negative reciprocals. For example, if you had one line with a slope of 1/2, the other line would have to have a slope of -2/1 to be perpendicular. Basically, you take each fraction, flip it, and make it negative or change the sign. So if you had a slope of -3, the negative reciprocal of that would become 1/3. It's positive because 3/1 becomes 1/3, and then you flip the sign from negative to positive. So slopes of perpendicular lines are negative reciprocals of each other. If you multiply their slopes together, it equals -1. Finally, we're looking at the distance from a point to a line. Recall that the shortest distance from a point to a line is the perpendicular segment from the point to the line. We learned that in the previous lesson. Today we're going to actually calculate the length of that distance using a coordinate plane. Remember, you're looking for a perpendicular segment from the point to the line, and then we're going to calculate the distance. So in finding the distance from a point to a line, there are three steps. First, you need to find the equation of the line perpendicular or parallel to the given line. In example 1, we're going to be looking for the equation line perpendicular to a given line, which means you need to find the slope of the given line, the line you're starting with. Then you need to find the slope of the new line. Usually it's going to be perpendicular, which means you got to flip the fraction, change the sign, and then you have to solve for the y-intercept of the new line. If you actually have a piece of graph paper or you're graphing it, it's a lot easier to see. You can maybe figure out the line just by graphing it correctly. The second step is to find the point where the lines intersect. So algebraically, you're going to have to set the two lines' equations equal to each other. If you are actually graphing the line, you'll be able to often identify where the two lines intersect, and that'll be the point. If you find that, you don't necessarily have to actually do the algebraic part. Finally, you're going to have to apply the distance formula to find the distance between the 2 points. So we're going to look at example 1a. Find the distance from the point 1, 0 to the line y equals -x plus 3. So the first thing you're going to have to do is find the equation of the line perpendicular to the given line y equals -x plus 3. So that's the starting point. You want to find the equation of that line perpendicular to -x plus 3 that goes through 1, 0. So what's the slope of this new line? You'll need to calculate the slope of the original line. So the slope of the original line, based on this equation, is -1. So the slope of the new line has to be the negative reciprocal of -1, which means you flip the fraction and then change the sign. So -1 is -1/1. You flip it, it's still 1/1, and then you make it positive. So the slope of the new line is going to be 1. At that point, you're going to look for the y-intercept by plugging in the slope of this line 1 and the given point. The point that the line has to go through is 1, 0. So you're going to find the equation of the line with a slope of 1 going through 1, 0. So remember the equation of the line is y equals mx plus b. You're going to plug in 1 for m, and you're going to plug in 1 for x and 0 for y, and you're going to solve for b. So 1 times 1 is 1. So 0 equals 1 plus b, which means b equals -1. So now you have the slope of this new line, which is 1. You have the y-intercept of this new line, which is -1. So the equation is y equals 1x, or just x, minus 1. So if you were to graph that, you would start at -1, a 0, negative 1, and go up 1, right 1, which notice goes through the point 1, comma 0, the one you're looking for, and that red line represents the new line. So that is step 1, finding the equation of the new line. And again, if you graph it, you know it pretty quickly. Well, it's going to go through 1, 0. It's going to be perpendicular, and you can see where the intersection is. Second, you're going to want to find where the two lines intersect. Now notice if you have a graph, it's pretty clear where the lines intersect. It looks like they intersect at 2, 1. Now you can also do it using formulas or equations if you don't feel like graphing it. So to do that, you would take the two equations of the lines, y equals negative x plus 3, which is the starting line, and then the new line that you just got, y equals x minus 1, and you basically set them equal to each other. That will tell you the x coordinate where the two lines intersect. So you solve for x, subtract x from both sides, and subtract 3 from both sides. So I'll just show you where that is. Subtract 3, and you get negative 2x equals negative 4. Divide both sides by negative 2. You see that x equals 2, which you can see from the graph that the x coordinate is 2. Plug x equals 2 into either equation and solve for y. So I'm going to choose the second one. So y equals 2 minus 1, or 1. So the point where the two lines intersect is 2, 1, which again you can see by looking at the graph. And if you can see from the graph clearly, you don't need to use the equations. 2, 1 is where they intersect. Third, you're going to now find the distance between the 2 points. So 1, 0 is your original point. 2, 1 is a point on the given line, and you're going to look for the distance between those 2 points. So you see on the picture that it's the segment in orange. So you can use the distance formula, or you can build a right triangle and use the Pythagorean theorem. So the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared, which is that. Or you can find the length of each side of the right triangle. So you notice that one's 1. That one's also 1. So the distance of that orange segment is the square root of 1 squared plus 1 squared, which is the same thing that you would get if you used the distance formula. So the distance is the square root of 1 plus 1, or 2. Square root of 2 is about 1.4. So all that work is to find the distance between 2 points. First, you find the equation of the new line perpendicular to the original line going through the point you were given. Secondly, you're going to find the point where the two lines intersect. Third, you're going to figure out the distance between the original point, which in this case is 1, 0, and the point on the line that you're looking for, which is 2, 1. Now example 1b, find the distance from the point 4, negative 3 to the line y equals 2x plus 4. So first you want to graph the line y equals 2x plus 4. So the y-intercept is 4, and the slope is 2, which means up 2, right 1. But I'm going to run out of room. But if you were to do that, this would be what the line looks like. What's the slope of this line? Well, it is 2. Okay, so there's 4, negative 3. You want the distance between 4, negative 3, that point on the bottom right, to that red line. So the slope of the line perpendicular to y equals 2x plus 4, you need to take the negative reciprocal of 2, which is 1 over 2, and flip the sign. So the slope of this new line is negative 1/2. Now you're going to need to find the equation of a line with a slope of negative 1/2 that goes through 4, negative 3. So to solve for b, you're going to plug in y equals negative 3, which is based on this point over here in the corner. X equals 4, and then the slope is negative 1/2. And now you're going to solve for b. So negative 3 equals negative 1/2 times 4, which is negative 2 plus b. Add 2 to both sides. And you see that b is equal to negative 1. So the equation of the line has a slope of negative 1/2 and a y-intercept of negative 1, which is y equals negative 1/2 x minus 1. So if you start at negative 1 and you go down 1, right 2, there's your line. Now notice that the blue line is perpendicular from 4, negative 3 to the red line. Your goal is to eventually find the length of that blue segment. Step 2 is to find where the two lines intersect. Now you can see clearly on the graph that they intersect at negative 2, 0. So at that point you don't have to do what I'm going to do in terms of the math, but I'm going to show you anyway what it is. You set the two equations equal to each other. So 2x plus 4 equals negative 1/2 x minus 1. To get rid of the fractions, we're going to multiply everything by 2. So 2 times 2x is 4x, 2 times 4 is 8, then negative 1/2 x times 2 is negative 1x, negative 1 times 2 is negative 2. Now you're going to solve for x, add x to both sides, subtract 8, and you get 5x equals negative 10. Divide both sides by 5. See that x equals negative 2, which is what you can see from the point. Now you'll solve for the y coordinate by plugging in x equals 2, do either 2x plus 4 or negative 1/2 x minus 1. Well, you do 2x plus 4 because there's no fractions. So y equals negative 2 times 2 plus 4. Negative 2 times 2 is 4, negative 4, excuse me. So negative 4 plus 4 is 0. So the coordinate of this point where the perpendicular line intersects the red line from 4, negative 3 is at negative 2, 0. But again, from the graph, you can see clearly where those two lines intersect. And if you see on the graph where they intersect, you don't have to go through the math. So that's one extra benefit of graphing, is that you skip the math part. Finally, we're going to look for the distance between negative 2, 0 and 4, negative 3. So we're going to use the distance formula or by constructing a right triangle. Notice if you construct a right triangle, you have a side of 3 and 6. So using the distance formula, you're going to take the x2 minus x1 squared plus y2 minus y1 squared, which ends up being the square root of 6 squared plus 3 squared. So 6 squared is 36, 3 squared is 9. The distance is thus the square root of 45. Rounded to the nearest tenth, and you see that the distance is 6.7. So these questions have several steps, but if you do a good graph and you make the points clear, you can skip some of the steps. You don't even need the equation of the line if you can see what the slope of the original line is, and you can graph the new line perpendicular to the original line, seeing where the points intersect, and only part you really have to calculate is the distance formula. If you have any questions on 10.5 part 1, you can see me during office hours or send me an email or leave a message on the Google Classroom board.